Okay, part B says, will the standard deviation of the sample be 4.2 inches? And the answer to that is no as well. Your one sample that you take is almost never going to have an average that's exactly the same as the population average, and never going to have, not never, but almost never have exactly the same standard deviation as your overall population. Your sample standard deviation and your overall population standard deviation will probably be different. I'm gonna disregard that second part of that question because I think it's a little tricky and a little confusing, more so than we need to get. So tonight you're going to have another simulation that you can run, and it's the NORM-SAMP. So normal sample, I think, is kind of what that's short for. So we're going to run this program with a mean and standard deviation that was given to us with that 65.3 and 4.2, sample size of 30, and it wants us to do at least 200 simulations. It says 500 is preferable. So I'm going to go to that on my webpage. And Sarah, this is kind of what I was talking about yesterday, that there's a different simulator that we used yesterday. And so yesterday I kept right under April 25th notes. And this tonight I'll insert April 26th above it, but this is the one that we're going to be using. Sample means simulator. Okay? So we have the population mean, which for these teenage boys we know is 65.3. We have the population standard deviation for these teenage boys, which is 4.2. We're going to run, it says at least 200, 500 is preferable. Well, let's do 500. The sample size is 30, and decimal accuracy will be 2. So when I get my list of sample here, numbers here, it's not going to be my sample proportion anymore, like it was last night. It's going to be all the averages. So when I take 30 kids, I'm going to have an average height for those 30 kids. And then when I shuffle the numbers back up and I pick 30 more kids randomly, I'm going to have an average height for those new 30 kids. Do you follow? So the numbers aren't going to be proportions anymore. They're going to be average height. Okay, and I just ran 500. The lowest average height was 63.07, so put that in for your minimum.
Is there any way to do that on my calculator?
On your calculator? No, you have to use a simulator for that. So for your minimum, put in 63.07, and the highest was 67.79. Now again, everybody hitting that run simulation at a different time is going to get slightly different numbers than those two. But do you notice that those numbers at least surround the 65.3? Right? The minimum's a little bit lower than 65.3, and the maximum is a little bit higher than 65.3. So they surround the average. The 63.07 is coincidentally very low. You must have gone and picked, I don't know, what makes someone short? I don't know for the low, but on the high end, you probably accidentally picked a lot of the basketball players. We'll just keep going with that example. Here's the key, and you'll notice on your worksheet, what is the next thing it asks for? The average of all these averages. So all of those 500 sample averages that are up there, we're going to take the average of those averages. And when we take the average of all those averages, we get 65.35. It's right here on your screen. So fill that in, 65.35. Now, that should be very, very close to your population average. Isn't it? 65.35 versus 65.3? Because you're averaging all of those averages. And the last thing it asks for is the standard deviation of the means. and that is 0.76. Now, the standard deviation of the means is much lower, because if you look at this simulator, look at all your numbers on all of your averages. These numbers are not varying by much at all, are they? Right? Because they're averages of samples. So, anytime you average things, the standard deviation of averages is going to be much lower, because you've already kind of centralized the data by taking an average. And so it's not going to deviate as much. But with the general population, you've got some kids that are, you've got some 16-year-olds that might be 7 feet tall, and that's just not going to happen when you take a sample of 16-year-olds. So if you actually looked at individual 16-year-olds, you will have some that are as tall as 7 feet. You will have some that are 6 feet 5 inches, but you would never have a sample of 16-year-olds that has an average height of 6 feet 5 inches. So your variability, once you take the averages, has already been cut down, which is why the standard deviation is much, much lower, only 0.76, as opposed to 4.2 for the whole population. Okay? So the variability of the sample means is much lower than, I'm cheating, and the reason for that again is because when you've taken the averages of samples, you've cut down on the range of numbers that you're going to be looking at. Versus if you look at the entire population, your lowest height might be 50 inches for a 16-year-old. Your biggest height might be 80 inches for a 16-year-old. And that, because you just need one 16-year-old to be that short or that tall. But when you're taking averages of samples, you're never going to have an average of a sample be as low as 50 inches or as high as 90 inches or 80 inches. State the mean, so state the average of the sample standard deviations. We actually can't do that. Well, we could do it, but we're not going to, and here's why. They want the average of the sample standard deviations. So here are the entire list of the standard deviations of every one of our 500 samples that we took. Our standard deviations are as low as 2.72 and as high as 5.4. So I will write those down. What is it? 5.4 and 2.72. I'm just going to write that down. 2.72 is your lowest standard deviation, and 5.4 was our highest. Now, the population standard deviation is in the middle there somewhere at 4.2. So if I were to average that entire list together, I should get something pretty close to 4.2. But unfortunately, that software doesn't average them for us, and I'm not about to add up all 500 of those standard deviations and divide by 500 to calculate my own average. So just to kind of get a feel here, I'm just going to average the highest and the lowest.
I have a question.
Yep, go ahead.
If we're going to make sense on this, wouldn't we need a simulation?
No, they're going to give you clips of pictures of the simulations.
Wow.
So they'll just give it to you. You won't actually have to type it in yourself. So the average between these two I just got to be 4.06. So we'll just kind of use that rather than taking the average of all 500. I'm just going to take the average of the highest and lowest because it's quicker. And we should realize those are pretty close. Okay? So, exercise 2 switches gears a little bit. Mr. Weiler took a sample of 30 16-year-old males and found the mean height of the sample to be 66.4. So, the sample average is 66.4. The population average was 65.3. The question is that overly high? Is that sample average overly high to the point where we should be suspicious as to where he got his sample from? Hopefully he didn't pull up to the basketball court and ask those kids and use them as his sample. Anthony just shook his head no in front of me. So you think that that's not significantly high enough to be suspicious. Is that what you're saying?
Yeah.
And my answer to that would be, you don't know. You have to let the statistics and the simulation kind of determine that for you. His gut says it's only 1.1 inches. But when your average is 1.1 higher, I don't know. It's really hard to tell, and probably we could answer in either way, but we got to run our simulation to test it. So if I go back to my simulator and I change my situation, I still have a 65.3 and a 4.1 standard deviation. Oops, that just went down. And I'm only going to run 100 simulations. Well, no, I'll keep it 500. We should talk about that. I don't want to avoid it. And a sample size of 30. I don't need to rerun it. I'm just going to use these numbers. How many of these were 66.4 or higher? And this is why 500 might be tough. I might go back and change to 100 because I don't want to count that much. Because there might be a lot of them. How many are higher than 66.4? Well, all of these rows are. And if you go back, it's from here and beyond. So that's how many scores out of 500? Well, each row is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. And we've got 1, 2, 3, 4 full rows, plus an additional 1, 2, 3, 4. So that's 44 scores. But remember, that's 44 scores out of 500. So 44 scores, or 44 averages, out of 500 were 66.4 inch averages or more. And 44 out of 500, just do your division, is 0.088, which is what percent? 8.8%, so approximately 9%. So, I think that number is kind of in between enough that it's all in how you sell it. Do you believe this sample came from this population? On the one hand, you could say no, because there's only a 9% chance we would have an average, we would have a sample average greater than or equal to 66.4. Or you might say, yeah, because a 9% chance, 1 out of 10, that's pretty close to a 10% chance. 1 out of 10 isn't the worst chances in the world, right? But I'm going to say in this context, I feel like a 9% chance is kind of low. So I'm going to say, you know what, no. Mr. Weiler obviously had a skewed sample. He might have gone to the basketball team for this one. Okay, it might not have been a good random sample. And then this says, quantify how likely this sample was to come from the population. There's only a 9% chance. There's only a 9% chance we would have a sample average greater than or equal to 66.4. Okay? So far, so good? All right. We are going to stop there. I'm going to give you your homework. You're definitely ready for it. We will, though, pick up with that last notes example tomorrow. Okay? So I'm going to give you your homework. And we had a quiz on Monday. Raise your hand if you were absent on Monday. Okay, so you two need to make that up. What do we have going on the rest of the day? You leave right away?
Yeah.
Or you leave in like 20 minutes?
We leave right away.
You do?
Yeah, we drive.
Oh, you drive.
Yeah.
When does the bus leave for Potter?
About 5 to 12.
The bus leaves at 5 to 12? 11:55?
It's about a half hour between, right?
But, so you have an hour?
No. We leave right away.
Okay, well, you're gonna stay and take your quiz now. You have what? So you have class?
Yeah.
Oh, after